Hi, hello there folks, welcome to Alaen Robotics. In this video we will be discussing how to write a C++ program that reverts words of a given sentence. And sample input is over here, reverse words are here, and the output for this given input would be here are words reversed. So with that tongue twister out of the way, yeah, it's really a tongue twister for me. Let's just head into the C++ program that does this. But just before we do that, I think we should have a look on the approach we're going to take. Now, as a beginner, as an amateur person who's coding in C++, how would somebody want to solve this problem? My approach would be to separate out the words out of the sentence first, like reversed and words and are and here would be placed separately, like taken out from the string they're stored in and stored separately as separate words, preferably in a memory location in such a way that they're stored on a stack or something, where first like reversed is entered and then words and then are and then here is entered, and I want to dump it in the opposite order. So then I would want here to come out first and then are and then words and then reversed. So yeah, that's a basic idea with which the first approach I'm going to take towards solving this program. So the simple code implementing that is over here. So in the normal C++, we'll be using these libraries. The IO stream would be used for taking in inputs and output, and string definitely, because we have to use a string, because you're going to store the sentence in the form of a string and then manipulate it, hopefully. I mean, not manipulate that string exactly, but you get the point. And then there is a S stream that also stands for string stream. I'll be using that library as well. I'll explain later on what usage is there. Now, most of you would have seen that we usually write the statement using namespace std, which includes the whole namespace, which comes with a lot of defined functions and classes. But I don't want the whole namespace, so we'll be just sticking with what we require. Like I need cout and cin and endl, so something that's going to be used always, and I just don't want to type std resolution scope operator cout cin again and again. So just for the sake of convenience, I'm doing this. Same goes for endl and string stream as well. And getLine, this is a function that I will be using in place of cin. What this does is, if you can see its usage over here, getLine, what this function does is, it tells us from which stream or from which object to take the input and store it in what variable. So we'll be storing the input for that's like present on the cin stream onto the string sentence. Okay, so that's what we're using for. And so we started out with the main code. We have the string sentence as the variable, and we have some counter to count the number of words that we have in the sentence, in order to like count and separate them and store them. So we would want to create an array to store how many words are to store the words on the stack, like that I mentioned. You can store it in an array basically. So we need to know the number to create a size of that array. So yeah, so once we get in that sentence, it will be stored into the sentence variable over here, and then I will iterate through the sentence. I have a counter with I variable equal to 0, and it's going through each of the positions of the given sentence, such that until it encounters the last character that marks the end of the string of this sentence string. Yeah, and increment. So in each of the positions of the string, we are checking if there is a place for this space character. So whenever a space character is encountered, we increase the counter, which increases the number of words. And we want to make sure that this is not at the last position, because usually when you give inputs, the last position is the last character, and we don't actually enter a space and put the last character. Maybe an example would be needed here for a better explanation. So if you can observe over here, suppose we were given a string that says CPP is amazing. So the last character over here is amazing, and there's no character. Usually it ends like this. So if someone happens to give the last character as a space, we wouldn't want to count that, because because in the code we are doing that towards the end over here. So how this code would go about is, like whenever the space character would be encountered, the counter value would be incremented to 1. Initially it was 0, so CPP is 1 word. After that, this space is encountered, and so the counter is set to 2. And then once this is done, there was no space encountered, and the last this last statement over here in the end, sorry guys, that one would increment its value to 3. So that's how we know that the number of words are 3. And so then we create an array, or a string array, that stores all these words. And the red line here is basically indicating that what we're doing is not something good. The program does run, it's supposed to be an error, but yeah, it runs. I don't know how, because I think at the runtime it's being created, the string array with whatever value of counter set. Suppose like here it's 3, so then we have an string array of 3 places having indexes 0, 1 and 2. So that's where this all the words will be separated in. How do we do that? We do that using string stream. So you have to first create an object ss, and this is its constructor function, in which we pass in the variable that we need to separate out into words. So what does this line of code do is basically the given sentence, wherever spaces are encountered, like all the words in the given sentences are stored in a form of a buffer, like in a story, like you can think of it like an array, where all the words are stored one by one in the order in which they were entered. So like if you take that CPP is an amazing example. First CPP is stored as a separate word, and then is, and then amazing. So then what we do, we go through the whole since we know the counting of the words, so we know there are 3, so we'll iterate 3 times, so like 0, 1, 2. And what we'll do is we'll pass on the words that are stored in this string stream buffer into the array that we created. So this basically places all the string character, the sentence string, now into an array of strings called words, with each of the positions having those values. Like in words of 0, CPP is stored; in words of 1, is stored; in words of 2, amazing is stored. So that's there, and then we print that out. But we would do that, we print it in the reverse order. So we set the counter the variable I to counter -1, so that would be 2, and this is greater than 0. So basically we are going from 2, instead of going from 0, 1, 2, we are going in the reverse order, 2, 1, 0, and we print that with adding spaces in between, because when we did that the spaces were basically removed. So let's just run this code and see how it works, right? So we click the terminal, new terminal, and I'd like pull this up a bit. So in order to run this, so mine is a Windows system, and I'm running it using I'm running the code on VS Code. So you can directly do that by pressing this run button, but since we need to take the input from the user, we have to do it in the terminal. So G++, and the name of the code is first up roach dot cpp, and then we need to give the -o flag, and this will be the name of the executable we create. So it takes some time, and you can see where is it? Here's the executable that's got created. So let's just run it. So /name first .exe, it's asking for string to be entered, so let's just give the string, let's just go with CPP is amazing, because I like that one. So number of words is 3, amazing CPP, there's our output, and this works. So if you followed till here, at least now you know how to reverse words of a given string, of a given sentence. This is good, but not quite really. There are some key issues over here that from the perspective of optimization, a lot can be done. First of all, we would need to get rid of this error. This is really bad practice. This has to be something like, if you can read the error given here, it expects a constant value, so it shouldn't be something that's dependent on the user, and that's bad practice, and we have definitely ways of overcoming that. And to be honest, this program or this methodology that we're using has 3 for loops, which is plenty. And I mean like we don't require that many. The process of where we are entering from from the string stream buffer into the words array and then printing in the reverse order, if you could do this in one loop, we'd be reducing a whole loop. So let's go to the second approach, guys, and see how better we can make this program. So here we are in the second approach. So the starting lines of the program are the same. I'm still using string stream and string header files, and basically the code is same till here, till this part. Like if you remember last time I had mentioned that this is the constructor, I mean this SS is in string stream object, and this is basically calling its constructor function with passing in the sentence that basically creates into separate out the words and stores them like in a string stream buffer. So but we create another string called ref sentence where we are going to store the output. Like one of the things that we did here was we printed out an array. It's like not the final output is not a string basically, so we would want to improve on that as well. So that's the reason we're creating only a string over here, and since we know the number of words, we're going through them. Now we have a temporary variable called word that stores the words that are coming from the string stream buffer. This again outputs one by one the words into one by one the words that are stored in the buffer into this variable called word, and then we use the insert function of the string. What basically this requires is 2 parameters. For the first one is indicating the position in where the given string over here should be stored into the string, and here is the string that we're using. So like as he said, CPP is amazing. So here in ref string is currently empty. Like I should have initialized it to empty, but random values there. But now when we insert it at the 0th position, it'll get CPP will be stored alone. And then if counter not equal to -1, I mean if it's not the last word, like the second, like in our case 0, 1, 2. So if it's not the second word, we would enter a space in the beginning itself. So basically now ref sentence would have space CPP stored, and then it will go to this loop the next time, and then is taken in place. So is entered in the start, and then a space again is entered in start. So it's now space is space CPP, and then finally amazing comes into the ref sentence. But we see that this is now I is equal to the final value of that is 2. I is equal to 2 counter, and this counter -1 would be 3 -1 2. And since space, we don't want, the whole reason for doing this is we don't want the final output to have a space in between, and we print out the function. So let's see this one now. So again we go to terminal, and I'm just going to take a new terminal over here, guys. So as I said before, g++ second underscore approach dot cpp, and the flag O, and I'm going to name it as second dot execute there. So let's just quickly run this. So let's just say here are the words needed, and so needed words are here. So you can see they've been reversed, and this also works fine. But as you can see, I'm sure you would feel that there is a need for some modifications, some improvements that can take place. We do have 2 for loops, and I think we can definitely reduce one. And if you're interested, we can also see how, I mean, instead of using the string stream, we can try to implement this by ourselves. I mean, write some simple code that does this functionality that we are using directly, that's inbuilt. And so let's have a look at a better approach, I guess. So we are going over here. Oh boy, so we've got rid of the string stream header file, as we're not going to be using that. And so initially we declare the sentence that we're going to take as input, and then the output reverse sentence, and this part we're taking some input. Now these variables start and length, These are to indicate whenever the start variable indicates the start of a word, and the length variable will indicate the length of the word. So what I'm trying to do is what we did here in two loops. Like first of all, we counted the number of words, and then we got them separated, and we then inserted them. I'm going to do this whole thing in one for loop itself. And as we are going through the sentence in which the given sentence is stored through the variable in which the given sentence is stored, we are going to be doing the whole functionality there itself. So yeah, we are going to go through the whole sentence till the null character is encountered. We are having a temporary variable called word of the string type, and so we are going to search for any space character, and hopefully that's and we don't want it to be at the end of the sentence. So then we have this formula for length is I minus start that updates the. Yeah, I guess you guys probably wouldn't follow that. I'll come back to that. I'll show you an example that explains that in detail, but just remember for the moment that length is equals to I minus start is the formula that we're using, and then the word that we're going to obtain is we're going to do it through the substring method of the string class. What it does, it takes in two variables, start and length. As I mentioned, we need to mention the starting position of the from where the substring has to start, like from a string, and the length, or how many characters it has to take. So yeah, and then once we get that word, the start position is updated to its new value, and like the previous example that we did, we enter the given word at the initial position, and we add the space because it's not the last word. When we come to the case of the last word, the length formula is modified a bit to I minus start plus 1, and the remaining things are the same, and at the same time we do not want to enter the space character in the beginning. So and then we just print out the final sentence in the reversed order. So let's just see an example for a more clear understanding. So we can go ahead with CPP is amazing, because I guess it's amazing. Not I guess, I believe it's amazing. So in this example we can see that CPP is this, and since the initial values of start variable and the I variable are 0, and as well as the length variable, all of them are 0, in the case is 0. So at this position, when the I value is 0, all of them are 0, then I slowly gets incremented to 1, 2, and then 3. It encounters a space character. So when it encounters a space character, the thing that gets updated first is definitely the I variable. That's the thing that's getting updated continuously. After that we have our length variable that gets updated, and the formula for the normal case, normal in the sense that whenever space is encountered, is I minus start. So it would be 3 minus 0 and 3. This would give the length of CPP, which is 1, 2, 3. So you get the point, and 0 is the indication of the starting point of CPP. So the substring method would then take in two parameters, the start as 0 and the length as 3, and these values would be a separate string would be created called CPP, and that would be stored in our ref sentence variable in the first position, and then a space would be entered. So then again our I goes on incrementing from 4, and then 5, and then 6 again. Oh, by the way, before that, the start variable is updated as well. Once the length variable is updated over here, the next thing that gets updated is the start variable I equals 1 to indicate the start of this new word is. So it starts at the 4th position, and when 6th is encountered, well, its length is determined using the normal formula I minus start. So you would go and say that in this position it would be 6 minus 4 and 2, and so the substring method is also able to easily remove out is from the given sentence, and that we go through the whole end, and at the end, because it's the last position, we have a slight change in the formula. And start variable always gets updated the moment length variables is updated in that same loop, in the next loop. In the same loop. That's the thing that's updated. So yeah, so after that we go around till then we reach the last case when I equal to 13. Well, since this is the special final case S, we will be using the formula for length variable is I minus start plus 1, so 7 13 minus 7, which would be 6 plus 1, and we would get 7, because we have one more character over here. Usually what was happening was we were using the space character and then we were minusing things, but here the space character is not, because the last character is a letter over here. That's how usually it ends. So we'll have to add one more character for the same previous formula that we were using. and that's how amazing is also extracted from the given sentence. So all that's left is to watch this program work. So let's just go ahead, and I've already created the executable this time, guys, so I'm just going to type in the code to run this /approach.exe. so let's just go ahead with CPP, because if there's any problem we can debug it easily, hopefully. So it's working, and so yeah, I think that this is one of the most simplified version. We have the whole thing working in one loop. We've written the code to separate out the words using the substring method, and then store them in the first place. Some of you might want to do the substring and insert implementation by yourself. Go ahead, I just don't want to reinvent the wheel, as they say. And so yeah, this is the approach I think a normal person would follow, and once they go on optimizing their code from their first approach, they can reach here. But let's just say that you want to do something like a magic trick for this question. Well, let's just get back to our example once. So we have CPP is amazing. For some reason, if you thought that the question of reverse the words in a given string was, like you thought it as like another common question in interviews, is reverse a given string. So if you confused it with that, what you would end up doing would you would have shifted the characters from, like, the last 13th at the 0th place, 12th at interchange, 13th at 0, 12th at 1, 11th at 2. So you would end up with something as if I'm suppose taking the G silent, it would have been Nizama space C space PPC. So Nizama CPPC is what you would have ended up with. Well, if you would have ended up with that, all you have to do, like the magic trick is, you have to reverse to separate words. So if you reverse Nizama, you would get back amazing, and that would be at the start of your string. And then C, if you reverse it, it will become is, and PPC again, as you reverse it, it will become CPP. If you didn't follow, well, it's the time to show the code. So we've got the things of the start, general stuff in the start there. So this is my reverse string function. What this function does is it takes the sentence, or the basically it takes the string that's being reversed, and at the same time we have the start and the end of the variables till where the reversal has to take place. So I initialize my I variable to start and j to n minus 1, because end over here is indicative of the length, and since our arrays are 0 indexed, we have to go back value -1. Yeah, and I less than half the value, because you want to, suppose you take the word function, like C, leaving out, I mean you would want to reverse till the half of it. So like you would want to refer to F and N, U and O, and then I, C and T. That's it. You don't want to reverse them again, because it's going to get back to the whole value. You want to do it till only half. So that's the reason it's there. And you're incrementing I as you go ahead, and you're decrementing J, so that positions are swapped. And so you can do that using a temporary character variable that takes in the positions one by one, and you can do the swapping till that character. So what we do is we've taken the sentence as stored before, and start is to indicating the start of the word, and we called in the string function on the given sentence itself. So as I said, CPP is amazing would become Nizama CPP. Nizama CPPC. So yeah, we've got it till there, and then we go through this whole loop. What it does is, whenever a space character is encountered, it calls the reverse string function, because so after Nizama, where it's encountered, it's passing in the whole sentence, but it's giving in the values for which the re-reversing of individual words have to be done. So so the first position would be for 0, and the space character would be encountered after G, N, I, Z, A, M, A. So that would be position number 6. So at position number 6, the value would be, so the values passed would be 0 and 6, and the word would be reversed into amazing, and in that way the start variable will be updated to the next value to indicate the start of the next word. This goes on till the last case. In the last case, start variable need not be updated, and as I mentioned before, it has to be i+1 for the last character. So let's run this one and see how it works. And yeah, so we'll have to go ahead and type in g++ fourth underscore roach dot cpp minus o fourth dot exe, and yeah, that's there now. You can see over here fourth executable has been created. So dot slash f fourth dot exe, yeah, that's the string to be reversed, and we can go with cpp. Yeah, I think we've been saying amazing a lot. Let's just go with cool because it is cool as well. So cool is cpp, and yeah, we're done. And so just forgive me for that last something I did. I entered something by mistake. So yeah, you saw it working, and let's just say that yeah, you're cool with this, you like these methods, but my favorite is third approach, and I'd like to show you something. Instead of taking single sentences, suppose you want to do it for a bunch of sentences, and that's the kind of question you would see probably on HackerRank or somewhere else, some other platform as such. So if you would want to do it over here on your Visual Studio Code, and then copy and paste it and run it there. So what you would want to do is you can go to view, edit a layout, and spread into this grid kind of thing, and you can close this one out. So here you can have like an input text file. We'll just close this one out. So we'll have an input text file where our inputs being read from, and an output is being written into. So I can go over here and first of all, let's just create it in input dot txt. Yep, so we have an input text file, and guys, I'm just lazy, okay, so I'm just going to copy the stuff that I pre-planned to reverse inwards. So yeah, this is the string that I decided that I would be reversing. So yeah, and I'm going to save this out, and let's just create an output txt where our output would be returned into. Okay, so output.txt we have, and that output.txt, I don't want it there, I want it in this window, right? So we have this here, and then I have a readme that makes my life a bit easy, and it's got opened up over here. No issues. So this is the code we're going to use. Copy and go here and insert. So on doing so, I just want to close this up and maybe pull this down. Yeah, pull this down a bit. Okay, a bit, not too much, not too less. Yeah, so what this does is basically we have we're going to be taking our input from this text file and writing it onto the onto this output text file. So input read, this text file is for reading the code, and from standard input, for the cin would basically go and take the stuff from here now, and cout would write it onto this text file. Yeah, but as you can see, we have mentioned the number of sentences we want to reverse, so we'd also have to make some other changes in the code. So I guess I have to check out my I did write that code again because I'm just lazy like that, guys. Yep, so I'm gonna insert this over here, remove the comments, and yeah, maybe not that one, my bad. I'll let that comment stay, I mean for this one. So we're counting the number of lines, and then we're going to repeat the code that we have for that many number of lines. So in this between part, we've got to insert till this, my bad, we've got to insert till this point. Live coding can be so scary. I'm gonna cut this from here and place it over here, and just gonna align those in. So so this, so I'm doing this if line 0 line equal to 0, because when we run the code, right, what's happening is it's running from this line 1 and this last sentence that's there is being left out. So to avoid that, we're going to say if the line equal to 0, that although it's reading the first line, I don't want it to get read again in my through when I'm iterating through this loop. I mean, I've read it once over here in the initial bit, but again when I'm going from getLine, it's coming from the start. So we're going to ignore if that's the first case, and we're going to copy this remaining code. I'm going to pick this up from here, and damn, shows a bit slow. Yeah, to here. I'm going to cut it out, and yep, and we're going to insert it over here. Actually, place it, enter, and yep, it's there. But yeah, the alignment's kind of messy, guys. Let's just like yeah, just do that, and like we can't see that, you know, it's part of this loop. So what I'm going to do is from the point that we kind of, this is fine, from here it's like a bit messy, so we're going to take this and oh god, from here till the yeah, you can say I'm an amateur by seeing this, guys, but Rome wasn't built in a day, and what we are trying to do is we are trying to shift this. So yep, so you're going to use control and the square closing square bracket, so that shifted all the selected lines to the right side, and so this is much more aligned, and you can see which for loops running, and hopefully this will work. I'm going to save this, and let's just see the sentences that we are using, guys. So we're going to go with CPP is amazing, borrow, rob, and convince or confuse. I like this one because its opposite is confuse or convince, and rob or borrow. Rome was not built in a day, and that's the truth, guys. And other sentences such as that, let's just run it and watch. And we've run it, and this is the output. Actually, yeah, I'm gonna just slightly pull this up, and so enter the string to be reversed. Amazing CPP. Okay, I'm just going to comment that out so you guys can see the output directly, rather than seeing that enter the string all the time. And save and run. So the code ran, and see, these are output, guys. So all of them have been reversed. CPP is amazing became as amazing as CPP, and like I said, confuse or convince, and rob or borrow. Inbuilt not was Rome, that sounded like a robot. So iCat or car it was, that see you did. Stage the to fire set to time it's. So I hope you had a great time with me and you learned something new, hopefully. And to be honest, guys, this is like my first video, and then I am an amateur, so I'm definitely looking for inputs from your side on what I can improve. Do let me know, and if there's anything else that you would like to know, you can definitely comment and reach out to me. I'll see all through the comments, because I'm new here, so I have to do that. And also you can check up the code. I'll be putting up the GitHub repo where you can see all these codes, and you know, get them on your system and try them out, and maybe let me know if there's some bugs that I can fix or some improvements that can make. See you guys, have a great day. It's been a wonderful one till now.